Hello.
Hello.
How you doing? It's not like we
It's
haven't
good.
talked today, right?
Yeah, it's been a long time. I was just
Yeah.
talking to you.
Yeah.
Was that Peter I was talking to a couple minutes ago?
Let
Also, I
me.
I, I apologize in advance if my camera behind me starts moving. My dog is playing right behind me. So what are you up to?
Oh, there you go. Sorry, I had a YouTube playing, and I could hear myself with like a 7 second delay, and then hear you with a 7 second delay, and I couldn't hear anything else. Anyway,
Got it.
I heard that you have a dog in the background,
Yeah, no, that was all I said. If the camera starts
breaking the
moving, it's the
wall, right?
dog. Yeah, exactly. Breaking the the brick wall that I'm
Yeah.
clearly actually in front of, definitely for sure.
Yes. Yeah. It's not fake. Um. All right, so I guess anyone watching, you'll have to do with the two of us today because, well, it's just the two of us today.
Yeah. Well, we can take this opportunity to talk smack about our wonderful colleagues. No, I'm just
Yeah.
kidding. Next time.
uh,
Next time.
yeah, next time for sure. All right, so what are we doing today? So we're talking about RAG and memory. Uh, Let me see what I actually put in the description of the episode. I have notes, but I want to make sure that we actually cover everything that we said we're going to cover. There you go. So we'll explain what RAG is, and we'll talk about how it works and how it's implemented in kagent. And then, yeah, we'll cover how that works. We'll talk about implementation of the memory concept that we did using Pinecone, and then we'll also show how to use query documentation tool to add relevant context to your LLM queries, right? And I think, Eitan, there might be something else that we want to talk about, right? You mentioned some like graph rag,
Yeah, I just
right?
think,
That we could,
yeah, we'll talk at the end about sort of more theoretically, like what, where RAG is, if there's, what are the different options, where RAG seems to be going, etc. So,
yeah. All right, so let me actually find my windows, and I'll share the screen or my window, I guess, and then we can talk about it a little bit. All right. Almost there. Almost there. There you go. We need a producer. If anyone is willing to help us as a producer, let us know. All right. So window, I think it's this one. Memory and rag, Excalidraw. Let me see. Let me know when I can actually, once I share it, we'll see it. Right? Yeah, that's the one.
yeah.
Yes.
Mhm.
Okay, let's just find.
Shameless plug for Excalidraw. Amazing software. Love it.
Yes.
I use it all the
Yeah.
time.
There's a nice one for iPad, but I'm not so good at drawing on like iPad. Maybe next time I'll try that. I think it's called Paper or something.
I think
The
I've seen that. And now like Apple has this like crazy ability to shift between apps and yeah, you can really
Oh yeah, I could like
thing.
just it would just magically be like I can present it. It's just I'm not good at drawing with that
Got it.
pen.
Got it.
That's a bigger issue than anything else. All
Yeah,
right,
yeah.
so yeah, so what is RAG? So as I said, retrieval augmented generation. So it's basically a pattern, right? It's a pattern or some sort of a process through which you can add fresh information or relevant context, basically before your request is sent to an LLM.
Should we maybe even taking a step back, should we even talk about why something like RAG
Yes. Yeah.
is
So
necessary?
yeah. So the thing is, the large language models are trained on a corpus of data, right? Corpus of information, and there's typically a cutoff date, right? Up until like they pick up all the data up until the end of 2024, whatever it is, right? And the LLMs don't know anything about what happens after that because they don't have that data, right? So they're
Or private
trained
data,
or
right?
private data, of course. Yeah,
Private
yes.
enterprise data, anything that's not in the open web.
Yes,
open,
yeah. Basically, that knowledge is static, right? So there's
yeah.
a cutoff date, and that's all the LLM knows about. So let's say you come up with a cool project or something, and you talk about it. It's on the internet, whatever it is. But if you did it after the cutoff date, right, your LLM will not know anything about it, right? Granted, it might not know anything about it, even if that's included. But anyway, right? Uh, right. But the point is, there's some static data, right, that LLM has, and there's a cutoff date, and anything after that that's not in there. And also, as you said, right, also with the private data, right. Let's say you have some private data, whatever it is, that's obviously like LLMs are not trained on that, right, unless you're explicitly training them on that. So they're not going to know about that, right? So let's say let's see how this works. So I need to get better at drawing this. So let's say I'm going to say, what date is today? May 15th, right? So we'll say, what happened on May 15th, right? Just a stupid example, right? Now, if I send this to an LLM, and you can try it, right? It'll probably say, hey, I have no clue what happened on the May 15, 2025, right? Because it doesn't have any relevant data, right? It doesn't know. So what you can do with RAG is, before you actually send this information, let me unplug it here. Come on. Oh, let's add a box, right? So you have some database. Let's just call it a database for now. So what you can do is you can send that query to a database. The data in the database, you can basically do a search for this query, and you might get some relevant results, right? So there might be something, maybe you have like the list of events here, right? And then you have May 15, 2025, kagent live stream, right? Or whatever it is, right? So there's some relevant data that's in there. So what happens through this process of RAG is that this relevant context, which is this one, gets included in your original request, right? So this time when the LLM responds, it's going to basically know, based on this context, right? It's going to know that, oh, okay, the user is asking me what happened on this date, and it's also telling me that there was a kagent live stream on that date, right? So the LLM might respond and say, on May, right, 15th, 2025, kagent live stream happened, right? For example. Is that like clear, Eitan? Did I explain it
Yeah,
well
no, I
or
think that
not?
makes total
Right.
sense.
And you can think of this database here containing your private data, right? Or the data that you have internal to your company only, right? It doesn't really matter what the data necessarily here is. It's this process is what it's
Yeah.
called RAG, right?
Yeah, and I think it's important maybe, or not, I don't know, maybe it's worth saying that all this is really doing is it's just enriching your prompt, right?
Yes,
So we
exactly.
talk
Yeah.
about how prompts are so important for these systems. What's really happening here is that you're enriching your prompt with data that is relevant to your prompt, right? So you're actually just taking
Original
your
query, right? That the user
original
sent,
query,
right?
right?
Yeah, yeah, yeah. However you want to call it.
Exactly. And so it's all you're really doing is making your prompt better with this solution. So
Yes. Yeah, exactly. Exactly. You're basically adding a system message, let's say, or however you're adding this to the list of messages that are being sent, right?
yeah.
So how do you, like, this was very high level. So how does RAG work? There's typically two high level steps, right? The first one is you need to have your data, right? You need to take all of your documents, your PDFs, your images, whatever data that you have to split the data up. That's called, you split them in chunks. So if you heard about chunks in the term chunk in when talking about RAG, that's what chunking means. Chunking means the way that you split the data to store it in a database. So you get the data, you split the data, you chunk it, so you get chunks like, let's say this is a chunk of data that you have. Then you take that data and you create embeddings out of it. So embeddings they're just vectors, right? With some numbers. I'm typing just stupid numbers here. It doesn't matter, right? So this is called embedding process, right? And there's a bunch of embedding models that you can use. OpenAI has it. There's a lot of open source embedding models as well. It's basically taking the string and representing it as a set of vectors, right? So once you have those embeddings are then stored in something that's called vector database, right? So vector database is a collection of vector embeddings, right? So that's like first step, right? It's like creating your data, right? I'm missing here the
Well, it's not that
splitting
it's
of
a
the data,
collection of
right?
vector embeddings, it's that the embeddings are the keys for the data,
Yes, yeah. So this data,
right?
if you look at it, it's gonna, and I can show it. Maybe we can show it here, right? Let me see if
Can you make that a little bigger?
yeah. There you go. Right. So this is how this specific data, this specific chunk is represented
Yeah.
as like a vector of numbers, right?
Yeah.
Uh, so
And
that's
so
what's yeah. Go ahead.
why is it important in this case that it's a like why not use just a typical data store?
Yeah, because embeddings have like what you can do is once you have the data represented in this way, you can search the database based on the semantic similarity, right?
Yep.
So you like typically you're not gonna do like where's my text? Select star from whatever, right?
Right.
From where text equals to like you're not doing a search like this,
Right.
right?
Because you
You're not
can't, because
doing
you don't know what people are going to ask.
exactly. I mean, you could, but you're not going to get good results, right?
No.
Uh, uh, but if I like, what you're going to do here is, let's say I ask a query that says, um, oh, "What? Oh, what's happening here? Need to get my shortcuts. What happened on May 15th, 2025? Right? This will get converted when you're doing retrieval, right? This gets converted into embeddings as well, right? So I'm going to get an embedding here from this string. It's not going to be the same. It'll be different, right? So let me just change it a little bit here. I know it's right. And then you're going to go with this vector. You're going to search for this vector in this DB, and you're going to say, give me uh, the most similar results, right? I'm making similar results for this vector, whatever it is, right? That's what's going to happen here, right?
Right.
Basically, the database is going to search for this, is going to do some mathematical operation, and it's basically going to return and say, well, this result, right, has a 0.78 similarity, right?
Hmm.
Similarity, and that's 78, right? 78%, right? So this query that was stored, like this result, this chunk that was stored in a database is 78%
Yep.
semantically similar to this query, right? So
And this is so I don't know if others have seen these words before, but like something like score threshold, distance threshold, like that's what this number that's
yes,
what this number is
yes,
really talking about. And I think when you're dealing with RAG or any kind of semantic similarity, this is really the most important number to tune, because this is where you decide whether or not, right, something is relevant. And of course, because it's a number, that number it's fungible, right? It's not necessarily so easy to figure out. But that's sort of what is so that's what they're talking about, right? How
Yes.
similar. And also
And stop
remember in
and
this case, what happened is not relevant necessarily, but May 15th is relevant. So you need to it's yeah, it's very you need to yeah,
yes. Yeah. It's not top N. It's top
okay.
top K, top similar, right? So score threshold and the top K means the number of results I want from the DB, right? So if let's say I do top K of 5 with score threshold of 0.50, right? It means that give me back find 5 results in a database that have 50% or higher similarity of the query that I sent in, right? So then what happens? You're going to get these queries back. You're going to get these results back, and then you can include them in the original query. You can send that whole thing to the LLM, right? And then the LLM will synthesize an answer and is going to return you an answer, right? Uh, Clear enough or no, Eitan?
No,
Anyone
I think that's a
watching?
I mean, it's a
Do we
great
have
start. I think
anyone?
it might be worth mentioning that, obviously there's like if you think about this process, right? Imagine you're doing this for, you know, hundreds, thousands, millions of requests, right? First of all, you're making network calls for every single one. And on top of that, you're also potentially stressing your database. Having an external DB is something that, on the request path can be difficult. So there, maybe it's worth mentioning that another way of going about something similar is fine tuning, right? So another way that
Yes.
people
Yeah.
solve a similar problem is they do fine tuning or they create their own models. Now, it's almost impossible to keep up with, if you're trying to get like let's say like the news, right? You can't fine tune the news into a model. It's
Yeah.
basically impossible. So it really depends on the use case and how much data you have versus how new it is, etc. And so there's always a balance.
Yes. Yeah. Yeah. There's all like you have to make a really you have to make sure you're making a right decision whether you want to fine tune or if you want to use like rag process or how do you want to solve it, right? Because you can get pretty far without fine tuning, right?
Yeah,
But then fine tuning would be to like actually, as you said, train the model on the specific types of inputs and outputs that you want to get, right? uh, All right, so let me actually I can show a demo right now, I think. Right? Yes. So let me go to kagent. No, that's not what I wanted. So we have this create is it big enough?
well, there we go. Yep.
Is this bigger? Fine.
Yep.
So we added this option to create a new memory database or memory that you can attach to an agent. Right now, we only support Pinecone, right? But we're planning to add support for more. So if you have any specific requirements for the vector databases that you might be using, let us know. So I'm just going to call this Pinecone memory. Why not, right? I just hope I don't have the one created already somewhere. I'm going to paste in my API key. So let me find that. So before I went and set up my Pinecone account, right? I set up a Pinecone account, filled it out with some data that they have in their walkthrough, right? So we have that prepared. I have an API key. We'll paste an API key here. I need to provide an index host. So this is the index host here. So let's do that. We can do a top K. I let me check what we default to. You don't have to provide it. So we default to top 5 results. And then the score threshold, we default to 0. So it's going to return everything. But let's do the score threshold of 50%. And then I also have to provide the namespace. So namespace is this one, kagent namespace here. Go. There's also this option that we have called record fields. This controls which specific fields you want to return or not return, specific fields you want to attach to the context when you're searching the memory. So we're not going to specify anything that means that both chunk text and these additional fields like category will be included in the response. But what I could do here is, if I only wanted to include this chunk text, I would just say, where is it? Chunk text here, right? And that's the only thing that's going to be included. Now, note that we're only storing a category in the actual chunk text. You could have multiple other attributes here. You could have like reference links. You could have customer IDs if you want to, right? There's all the different things that you could store here that might make sense for your scenario. All right, so like this. There you go. So I've created a memory. It's going to show up here. Now, you might be wondering, where is the embedding and all that magic? The reason we picked Pinecone as the first memory provider, I guess, for kagent is because it has built-in embeddings, meaning I, as a user, don't have to figure out how to create embeddings of my query and then send those embeddings. I can directly send the string, and then Pinecone will do the embeddings for me. It's going to use this llama text embed v2 model to do the embeddings, and then it's going to do the search and it's going to return, right? But in the future, we will add the ability where you can create an embedding model, right? You would create probably like an embedding model config, right? And then use that as your embedding model, and we would do the embeddings on the fly. All right, so I have that. So let's create a new agent. And I'm trying to, okay, so yeah, let's create a new agent, and we'll see memory. I'll just call it memory agent, memory agent, and we'll say answer users questions, right? I'll pick GPT-4, and then we have this new memory field here where you can pick the memory, one or more memories that you've created, which is basically connections to the database. But let's do it without. Yeah, let's do it like this. So let's create it with go, and then if I can find it, where is it? Memory agent, right? Let's click on this. Come on. Not what I wanted, but there we go. All right. So we have our memory agent, and we'll say, let's see what it does when we say what happened on let's say May 14th, 2025, right? So the model itself doesn't know anything about that date. So I'm curious. Yeah, there you go. So it's going to say, oh, this is what, right? So the cutoff date is June 2024 for this specific model. So it doesn't have any information about that date. So what I can do is, if we go, it's just weird that it didn't do a search, right? So what I can do is I can add a record to the kagent namespace, and we'll just do ID whatever. And we'll say on May, did we say 14th?
Yeah.
14th, 2025, a live stream, it's a kagent live stream happened that talked about RAG and memory, right? And if this doesn't work, then we'll do some live debugging. All right, so this was added. So now if I go back to the browser here, and we can check here, what are we going to get back? So if I do this, search, right? There you go. So you can see that it's a very low score. It's 49, like 39, which is weird, right? Maybe we need to, let's see, let's add another one. Just want to, because I think I did a too low of,
that actually
or
kind of
too
makes
high,
sense though,
right?
because the only thing in common is the date.
You're right. Yeah, you're right. So let's say
Which again
we
is
can.
one of
Oh,
those
let's do.
downsides of
Let's see.
RAG.
Hey, live streams happened in May. Let's see, in May. So it is very important. Yeah. So it's still finding this one. It's still low. low. What live streams happened in May? 37. My live streams on RAG happened in May. Oh, there you go, 50. Right now, I bet if I say RAG and memory is going to be even higher, right? Yeah, 54. So let's try this. Let's see. Yeah, for some reason, why isn't it picking it up? We might have to debug it, A10.
Oh no.
Oh, it's clarify which platform, as if it would know, right? That's odd. Let's debug it.
Okay,
Let's
go for
debug
it.
it. All right. Let me share my screen so people can actually see debugging this. All
Yeah,
right.
it should at least say that it. Oh, wait, what was your threshold? Was it 50?
It was 50, but
Yeah.
let's see. I'm just trying to reshare my screen. There you go. It's a live debugging session. That's why we need Christian here. He's way better with demos than I am.
He prepares them to the T.
Yeah.
Uh,
I'll zoom in a little bit here. All right. Is this actually we can make that one a little bit smaller as well, right? All looks
yeah.
good, I guess. All right, so here's our Pinecone memory implementation, right? And all it's gonna do is it's gonna query for the results, right? And check what's there. So let's see. So let's see the memory. So it is there, right? It has the score threshold at 0.5. We can lower that one. The top K is 5. Let me just close my env here so I don't.
Leak any yummy secrets?
Yes, yeah. And then what I'll do is I'll stop this here and let's add. Is it update? I think it's update context. Actually, query. Query is where we do the search, right? It's here. Query, and then we're gonna get the response here. So let's debug this. Let's do that. Oh, yes, that's what I want to debug. This is gonna start up, and we can try restarting it here. Oh, yep, it's coming up. I didn't expect this to turn into like a debugging session, but hey,
You
that's
know,
what
it
you.
didn't yeah, I wonder what happened. You have this debug situation down to a science. I'm out here still putting in print lines.
No, it's actually once you set it up, it's not like it's pretty straightforward. All right, so
No,
now
it's
we
definitely better.
so let's see. Now we're debugging, right? And now we can say what happened on May 14th, 2025. Let's do a search. Oh, there was something. There was something. There were some red things. Did you see?
I did see those red things.
Let's see what those red things are. It's probably something stupid, as it usually is. We'll have to do it again. We'll have to do it again.
But it was interesting. Yeah, you'll probably have to
Oh,
increase
there.
the
Oh, what did I do?
you'll probably have to increase
Uh,
the context.
let me
Oh,
see.
where
No,
is
no,
it?
no, no. Forget about this. These are like my other breakpoints that I had set up from previous debugging sessions.
Yeah, you might have to
Get this back
increase the
here.
number of messages in your terminal.
How can you do that?
Ah, there's some setting.
Uh,
Do command comma.
let's see. Settings, right?
Yeah,
Profiles, cursor settings.
I don't know. No, it's
Probably
definitely
not.
not cursor settings. It's just
Editor?
yeah, yeah.
No, it's command, right? Terminal.
No, terminal.
Terminal limit
Scroll. Do
scroll.
scroll. Yeah,
Session
there.
scroll back. There you go. So let's do 1000.
Yeah.
All right. Let's try this again. Okay. Let's close this. Go. Oh, now it went to it. What the heck? There you go. So we got a hit here. So it's going to search that namespace, right? Top K is going to be what? Oh, because the top K is 0 for whatever reason.
Mm,
There's a bug. We can fix this. At least now we know what's. So we're basically saying do a search, but then return me 0 results, right?
that's just
So
not going to get you anywhere.
yeah, exactly. So memory, let's edit the memory. And then we can add, if I can remember, what are we calling this? Pinecone, memory.
Memory types.go or something.
Yeah, memory types. Nope, memory. This one, right?
Yeah.
Writer index top K. There you go. So we'll do top K. Whoops.
That's
Top K will be, let's do 10, right? Okay,
whoa.
that's too much.
No, I'm just kidding.
All right, let's do debugging again just to make sure that it's all good.
Oh, I just saw the kagent logo blink.
You saw what?
Nothing makes me happy. The kagent logo and you're on the right, it just blinked.
Oh yeah. So
That's my
this,
favorite.
by the way, yeah, this one is blinking every I don't know how many seconds.
No, I think the one in the middle of the screen did too.
Oh, that one could be. Yeah, the error one could be.
It's a discoverable entity. We actually didn't know until just now.
Well, I knew it, but because I
Oh,
added
okay.
it.
I did.
I added it
I
in
noticed it.
explicitly. It's one of those things that like you can't check that in by mistake. You know what I mean?
Yeah.
All right, let's see. Second try. Query. Okay, so we're querying. Let's see what the top K. Why is it 0? That doesn't make sense. Okay, we'll do. There's a good bug for someone if they want to fix it. Why am I opening this? All right.
Is your
Yeah, so
controller running?
it is. So the namespace.
You can just live edit
That's
that number,
correct.
right?
Yeah, that's what I wanted to do, but I'm
But I
just.
don't think it'll work because it already timed out.
Yeah, I know. Let's do this. But the default's here to 5, so well, let's do this. Oh, I can just create a new one, right? Whoop, go run controller. Yeah, actually, let's do that. Let's go to view memory. Oh, it's not running. All right, let's close this. UV run. Go. This will come back, and we can fix that. I don't know why it's 0. It's odd. Oh,
Yeah,
maybe
it's odd.
because I didn't set it. Maybe it's defaulting to like an actual 0, the number, not like null or empty, right? Oh, now
Yeah, we
it's
should.
saying 10. No, it's fine. Now it's saying 10. So it did pick it up, but I don't know why. Let's try again. Where is it?
We should probably. Well, your thing is zooming around. Do you? Oh, it stopped. Okay. Do you
Hmm.
have it running in Kubernetes as well as locally?
I think I delete. Oh, that might be.
Oh,
No. I don't have it.
okay.
It happened a couple of times,
Yeah, I
but
remember solving that once. So
I think we'll have to do a debug again here because it's even though it's saying it's 10, it's not it's not picking it up for whatever reason. But let's do that. Okay. Is everyone enjoying watching me debug here?
I am. I haven't. I honestly haven't touched this code yet.
It's I think the hard not the hardest part. It's one of those things that you're like, oh, this is probably going to be a pain to set up the debugging and everything. But then once you set it up, it's so useful and so easy.
Yeah.
Well, actually, it wasn't that hard to set it up. Why is it? Oh, because I still have it
Because
running
you still have
somewhere.
it. No, in the first
Oh,
terminal
it's here.
there. Yeah.
Yeah, you're right. I don't know why I had it running again. There you go. Yeah, but it was just one of those things where you're like, oh, I don't want to set it up, but then once you set it up, that's what it is pretty much.
Yeah.
We should add this to our docs I think. Yeah, I
Or
think
even
it will be
just, I think we can
useful.
check it in.
Yeah, you're
But
right, because it is generic enough. There's
yeah,
no. Yeah, you're completely right. We'll check it in. Okay, there you go. There's a breakpoint. So let's see what's going to happen here. Oh, now it's getting 10. Okay. All right. So record fields is going to be none, which is fine. There you go. So let's see what we got. Did we get any results? Oh, we did. What the heck? Why isn't it working? That didn't make any sense. All right. So let's get the score of the first one. So it's 37%. Our score threshold is 5. So I'm going to go here and
I
I'm just
think
going to run
results
it
is going to be
through.
0.
You think? Yeah, it is.
Yeah,
You're
because
right.
you
You're
didn't,
right.
you need
We
that tailored query that you came up with.
Oh, you're right. You're right. What was that one? It was this one,
That,
right?
I think it's
Yeah,
that,
yeah,
yeah.
yeah. Well, let's try that. Let's see again. Okay, and let's go. Yep, let's do 5. Yeah, now we have one result. There we go. And it is the one that we wanted. So let's do that. Oh, now it's showing up.
There we go. Hey,
Yay, all right.
sometimes you just need
Oh,
some
why
luck.
did I click
Luck.
back? Oh, no.
No!
Let's do this. Let's remove the breakpoint and let's
Well,
make
after
this
my PR
full
goes in, this
screen.
won't be a problem anymore because you can just
Yeah.
take a look at the old
Yes.
session.
Yeah. Yeah. All right. So what was it? This one was one live streams on Rag and Memory happened in May, and the reason we have to be this specific is because we set the threshold very high. Right. There you go. So I'll just do play here. There you go. So we have this memory retrieval thing that's going to say, oh, in May, this is the actual result that was there, right? And it's going to say, oh, there was a notable live stream on May hosted by kagent and focused on blah, blah, blah. And then this is what it makes up, right?
Yeah.
I mean, this is the response that the LLM adds to whatever we added it, right? So basically, these two things get sent to the LLM, right, as a context. And then you could see we could do something else that says, yeah, but it was, I don't know. Do we want another example? We could do it. But yeah, I think it's clear enough, right?
Yeah. I think that makes sense.
Yeah, it makes sense. It's going to go and it's going to retrieve
Yeah. And I
the
mean, and the nice thing is about using
information.
the UI is you can see all of the relevant pieces of data that were added.
Yes. Yeah. Oh, actually, we could do this. So if I copy this and let's add a record, we can say namespace this, some ID, and then on May further, what else happened yesterday? Big storm happened in Seattle. It
Yeah,
didn't,
but
but
now you're gonna have a hard time matching both at 0.5.
oh, you're right. Oh no, it has to be something with rag, right? Yeah. Was there a storm in Seattle? I wanted to do so. It's gonna like capture the two of. Yeah, no. In May 2025. Oh, there you go. And then I don't know why it doesn't show the result,
Because
but
it's just making it up. It didn't even get the piece of memory. It actually just decided that that happened.
it knew, right? Was there a storm in Seattle in May 2025? Let's see. It is looking it up. There you go. Yeah,
Yeah, but
yes, there was a big storm. All right. Now I'm gonna. All right, let's move on a little bit. I have another thing that I wanted to show, and that's the
the docs, yeah.
the doc tool. Yeah. So let me go to. I'll just
Should we
use the
briefly
same.
mention Doc2Vec also?
Yes. Yeah. So we have this tool called Doc2Vec, and we can. I don't know. We'll paste it in the descriptions, or just come to like go to our Discord or our website. You'll find it. But what this tool does is it's going to do this. It's going to help you do this part, right? Where actually the data preparation, right, which is this part and this one, right? So it can take in I think GitHub, let me go here and see exactly what it can do. So it can retrieve GitHub issues and comments. It can crawl websites, right? It's going to basically use the sitemap and then go and extract and find all the pages. So it's going to get all that. It's going to get all it can get all the GitHub issues if you want. It's going to extract the content. It's going to convert HTML to Markdown. It's going to do the chunking, right? It's going to do the embeddings, and then it's actually going to go and create a database, vector database for you, right? So all that data preparation thing, if you want to do, you can do it with this tool here. We also have a walkthrough under our docs in the examples documentation agent, and this one will actually walk you through on, well, clone the repo, install, right? Configure what you want to do, what you want to bring down to your database. It's going to go and it's going to do the embeddings. And then it's going to go and tell you how to build an image that's going to host that database, deploy it to your cluster, and then how you can use it in kagent, right? This specific example uses an MCP server to expose that data, right? And then it's going to use it as a tool basically to retrieve the query, the data that you've created, right? But on top of that, we also have an existing tool that's called query. Is it?
Query tool.
It's called Query Tool. I don't know why I have two. Oh, I know, because it's my development thing. So it's query tool, and this tool has access to databases for Kubernetes, Istio, Argo, Argo rollouts, Helm, Prometheus, Gateway API, Glue Gateway, K-Gateway, Glue Edge, OTel. Doesn't have access to Cilium yet, and Ambient. Oh no, actually it does.
It does.
Right?
It does. It does.
It does. Yeah. It does. Right. So this is all pre-created. You don't have to you don't have to do anything. You can use this today. Right. So if we do that, actually, let me go back. And I'll just add instruction. Answer users' questions. Make sure you always use the query tool to search for relevant context. Let's put it that way. So in this case, the RAG, the RAG process is going to be done via the tool call, right? So let's go here. And you say we have the query tool here. So let's say we want to ask it something about Istio. And say how do I configure MTLS in Istio? Right. Let's do that. So you'll see there's going to be a tool call to that query documentation query tool. Right. It's going to query for configure MTLS in Istio. The product name, it figured out that we're talking about Istio, right? And then we actually got results back, right? I can't scroll because it's automatically scrolling to the bottom. But let's wait until this is completed, right? We need like Jeopardy music when this is happening. There you go. All right. So you'll see that the results are from the database that we're hosting, right? And see the distance here. So distance is the distance, aka threshold, aka what do we call it else? Score threshold, distance, result similarity. Right. So in this case, it was 72%, right? And we have the content here that talks about specifically about how to configure MTLS in Istio. Let me close this, right? And then the agent created a response based on that data as well, right? So this is how you could ground ground your agent in actual specific data that you have, right? And then the same thing about tell me about, let's see, tell me about route tables in K-Gateway. Let's see. This one will do another search, and this time is going to use the K-Gateway database, right? Come on. What happened? Am I still debugging?
I don't know that route tables even have, or K-Gateway has route tables.
Doesn't it have? I thought it does. Oh, something
HTTP routes.
something is broken. Oh, we got a breakpoint. No? Why is this taking so long? Demo gods are not with me today.
When you're debugging, it might be slower, so you can just serve it.
Yeah, I'll just serve it. But anyway, you I hope everyone watching gets the gist of what this is and how it works. All right. What else, Ethan? Do you want to talk about like
Yes.
some of the new,
Can you send me
let me just.
that Excalibur you were using, and I'll continue on that.
Oh yeah, perfect. Let me just remove this here. We'll find the Excalibur.
You could just fax me the link or whatever.
There you go. Shareable link. Excalibur. I'm sending it to you. There you go. And once you share your screen, we'll add your screen. You got it?
Share screen. Hold on. Share screen. Wait.
Do you have
Allow?
to restart?
No. Share this window. Can you see my?
Yep.
Okay, cool.
Yes.
So yeah, my Excalibur is in dark mode. So sorry for the. I actually just don't know how to switch it. So that's where we're at. Anyway, okay, so the thing that I want to talk about is I think it's it's actually funny that the demo went the way it did because we actually explicitly showed the limitation with RAG, right? When you're dealing with something like RAG, you need this semantic similarity, but it's really very it is and it both is and is not related to how human speech and connections actually work, right? So, for example, with the embedding about kagent and live stream, etc., right? Imagine you had um, like you asked a query about kagent, right? And you asked and it gave you some information, or you asked specifically about a live stream, right? In a traditional RAG system, it would only be able to return things that are specifically about the live stream or about the kagent live stream. But like, what if you wanted, let's say, more information about just kagent, right? That would be really hard because all of a sudden it needs to decide to semantically match entities, right, as opposed to just parts of the sentence, score thresholds, etc. So Microsoft released this idea of what's called graph RAG, and basically what graph rag is it's similar to rag. Um, hello, Praveen. Nice to have you. So it's similar to rag, but instead of a traditional vector DB, it uses more of a graph DB concept of what are called um, communities. So a community is basically a group of edges or nodes within a graph that are densely populated. And so basically by using a graph DB, right, what you're able to do is you're able to build unique connections and get data that's relational, right? Semantically relational, as well as things that are semantically similar, right? So imagine
Mm.
you had some node, right? That was, so let's say, this was my node. This is my first node. Oh, no, that's not what I meant to do. This is our kagent node, right? Kagent, right? This is our K. Wow, why is everything green? That's horrific. Okay, this is our K agent node, right? Now, K-agent, right, is related to a bunch of other things. So, K-agent might have, let's say, some live streams, right? So let's go from kagent over to our live streams. Our live stream node, right? And so now, right, kagent, when you look up kagent, you're going to get information about live streams, right? So there might be some. This is our live stream. It's called a community, right? So now we have one that happened on, kagent live stream. I'll make this bigger. But something like this, right? Semantically, you can think of it like this. It doesn't actually get stored like this, but I think just for the sake of it, kagent live stream May 14th, right? That's great. So then now let's say we have another one that's like, I don't know. What else have you live streamed lately, Peter? MCP live stream,
Yeah,
right?
yeah. But it's any like
Uh,
this live stream
April 12th.
community, right? You call it
Right,
community.
exactly.
So this live stream would contain anything about live streams, not just
Yeah,
kagent specific, right?
right. So then you also have, see, now for MCP, right? You have this link, right, going from, oh, where did Peter go? Okay, well, anyway, so we have the link, right, going from MCP to the live streams. So basically now, in a sense, what you're able to do is you're able to make you're actually able to sort of draw conclusions, right? So you can say, you know, what live streams happened and what were they about? And then by finding out about live streams, right, you can then find out about kagent
Mm,
and about MCP, right? And so it's and building this graph is obviously much more complicated than building out a traditional RAG database. So with RAG, right, all you're doing is you're embedding and you're throwing it into the vector DB. But with a graph DB, with this graph RAG, it's called, and this is kind of a concept out of Microsoft. What you're doing is you're actually forming entity relationships, and so to do that, you actually need to do entity like removal from the original prompts and the data, right? So you actually need models to both get the embeddings, but also to pull up the entities and describe the relationships between the entities.
mm.
So it's a much more involved
Involved, yeah.
process. Yeah, it's much more involved to actually create this graph of data. But you can imagine once you have it, right, how much more useful and how many more like how much more you can figure out about a given topic
Yeah.
just from the data store, right? As opposed to right now, if you just have a traditional RAG database, what you'd have to
You're
do
just
is,
adding entries, right? You're basically just doing embeddings, you're adding entries
yes,
and storing them. Whereas here, you do the first part as well, right? You get the
yeah,
embeddings, but then you also have to go and update the nodes,
yeah,
right?
exactly.
Based on whatever new information you have to either update one node and then update downstream nodes or any connected neighboring nodes as well if needed, right?
Yep, exactly. And you can do there's multiple ways also. So you can do like community search. So what that means is you can do searches that actually only would say be in the live stream community, right? And so what that means is you'd only get data there. You can also do global searches, which obviously take
Mm,
longer, right? But
yeah.
then involve, let's say, you know, over here you have,
How do they do it? Is there like a concept of first level neighbors or second level neighbors, or how do they like or community or whatever you want to call it,
that's a
right?
great question. I am not
Oh,
nearly
okay. But
knowledgeable
I
about
would
the
assume there is a
math.
way, right? There's
Yeah,
probably a way that says do it in this community only, do it global, or
yeah,
here's the range or the node distance or whatever that I want to
right.
include in the results. Yeah.
So now, right, you potentially have something like this where, you know, the right, you have sort of, again, you have all of these different communities. So this might be your open source community, right? And so all of a sudden, you know, you have something like this, right? So, and all these things end up connecting to each other. And so you have all this data that's interspersed and connected. And so rather than wasting cycles for the LLM to figure all this stuff out while you're um, while you're computing, while you're prompting, while you're actually interacting with it, right? You can do it all ahead of time. It's similar to like,
Mm.
you know, a traditional programming, you know, concept of like you know, like how much work do you do up front versus what do you do on the request path, right? And a lot of times when you're worried about, in fact, most of the time you prefer to do work like ahead of time because then when the actual user needs to do something or whatever, right, it's much faster. And so this is the same thing, right? You build
And cheaper
these
probably, right?
and cheaper in the moment. I don't know about cheaper
Yeah.
overall. Well, maybe because you're only computing it once, right?
Yeah.
You're
Yeah.
computing it once for everyone to access. So it's probably cheaper too, yeah. But
Yeah,
anyway, so
because
that's
yeah, that's an interesting, yeah, and they have it in autogen, right? It's I
yep.
think Mem Zero is using using graph graph rag as well.
I would not be
Wha
surprised.
Yeah, because I was looking at that. I know they added support for it, but yeah, that's interesting. So you can get more relevant information
Yes.
than just from
Yeah,
the
exactly.
vectors.
I will
It's almost like,
post.
yeah, vector store is linear pretty much, right? And this one is
Mhm.
more of it's linear if you do it in one community only, right? But then
Right.
it's much more valuable if you expand that community to
But
the neighboring communities,
even
right?
in a single community, it can still be very, very valuable. So, but
Yeah.
yeah,
Oh yeah, yeah, for sure. Yeah.
because the communities are actually, they can be paragraphs or they can be, so the chunks, right, are up to you as well, right? So you can
Yes. Yeah.
spend more to build the graph and get more fine-grained data,
Yeah.
right? So
Yeah,
this is
like
something to
chunking
implement too.
chunking is another whole topic of
Yeah,
like what are the best strategies to chunk and split the data so the context is actually preserved within the chunk, right?
yeah,
You don't want to store the data that doesn't have any semantical value in a chunk because it's going to be
right.
useless, right? So you need to
Yep,
figure out. Yeah, I think some of these providers are also like in kagent right now we only have like a read only, right? We don't have adding to memory yet. But there's like you can think
yet.
about
Bum, bum,
yet
bum.
exactly, right? You can think about adding to memory is as a most primitive type of implementation is just yeah, just get the user query and then whatever was the response and just store that, right? However, there's like strategies where you can, well, let's summarize the response or let's extract the valuable pieces from that response and just store that instead of just storing everything, right? uh yeah, so it's a lot of like it's a whole pipeline that one needs to set up and figure out how they want to store it, right? And chunk it, embed it, right? Store it, what do you want to use in the back end, and then how to retrieve it as well. So all right. I know Praveen
Cool.
asked about or said the distance helps you understand how closely the things are related. Yes, right.
Yeah.
It's and I'm assuming the graph thing does the same thing. It gives you back the some sort of a percentage of similarity or something, or is it just right? It does.
Yeah.
Yeah. Yeah. All right. Anything else to add? A10? No.
I don't
Yes.
think so. I think
No.
that's a good, we covered a lot of stuff today
Yeah. Yeah. With some live debugging, of course.
with some live
That was
debugging.
unplanned. But, all
Hmm.
right. Well, it was nice chatting with you. Thanks everyone for tuning in, and we'll be, I think, back next week. Right.
Yes. All
All
right.
right.
See y'all next week.
Bye bye.
Bye. Bye
All right.
all.